I'm going to go over factoring by grouping. We're ready. All right. Factoring by grouping is useful when you can use it for 3 terms, but it's necessary if you have 4 terms. So I'm just going to use it when you have 4 terms. And the focus of factoring by grouping is that it's greatest common factor. We do greatest common factor several times. And that is the main I lost my word. Process. That's the main process. Okay, so you look at the polynomial, the entire polynomial, and factor the greatest common factor if there is one. If that's possible, go ahead and take the greatest common factor out first, so that then, starting then, all of your numbers will be smaller and hopefully more familiar and easier to work with. Then you split the polynomial into 2 groups. That's why it's called factoring by grouping. Once you have 2 groups, you factor greatest common factor from each of your 2 groups. So you'll look at the 2 terms and find greatest common factor for that one, and then the second group, greatest common factor for the other one. Then write the common binomial. And I call it that because when you do factoring by grouping, you should have a binomial that matches. If you don't have a common binomial, then that should tell you that you didn't pull out the greatest common factor. There should be something more to pull out. The other thing to know is that if you don't see a greatest common factor for each, you can always use 1. So if your binomial seems like it's prime and there aren't any common factors between the 2 terms, just say it's 1. Also, the sign of the greatest common factor matches the sign of the first term of the group. And that was a rule that we used when I introduced greatest common factor again as a reminder this last time. Okay, so greatest common factor for each of the 2 groups. Write the common binomial. This will be one of your factors. And then combine. Oops. We're going to combine the GCFs and write that as another binomial. Combine. And then look and make sure you're finished factoring. There may be a difference of squares. There may be an additional greatest common factor to pull out. Just make sure that there is no more factoring to be done. Okay. But the big plan is that we're using greatest common factor a lot. So here I have an example, 4x cubed plus 12x squared plus 8x plus 24. And when I look at the entire polynomial, all of these coefficients and the constant, all of these numbers can be divided by 4. So first, I'll factor 4 out of everything and write my reduced polynomial. Make sure that you always write the 4 with your other factors and don't just throw it away. I can rewrite this polynomial as x to the 3rd plus 3x squared plus 2x plus 6. So that was step 1. Then we do make 2 groups. So for my first group, I'll just do first 2, second 2. You can rearrange these and make your groups in some different way if that makes you feel more comfortable with it, but first 2, second 2 works. So that way you don't have to rearrange stuff. For these first 2 factors, the greatest common factor is x squared. For my second 2 factors, the greatest common factor is 2. The x squared is positive because x to the third is positive. The 2 is positive because I have plus 2x. So that's what I meant when I say the sign will match the first term for whatever it is you're factoring. Okay, I'm going to clean this up a little and write it so it's easier to see. And I will lean on you guys to tell me if you prefer to always write it this way or if you feel like it's not necessary. Well, or you can choose that for yourself. I'll write x squared out front and my simplified binomial, which will be x plus 3 if I factor out x squared. And then my second greatest common factor is 2. And if I factor 2 out of each of these terms, that leaves me with x plus 3. So here's where we have a common binomial. Each of these groups has an x plus 3. So the greatest common factor of this polynomial now is x plus 3. And we can do this like we simplified in the previous lesson, where if you have a common factor, yes? It doesn't have to have the brackets. It's just that you can write parentheses, but the 4 is multiplied times everything. So you can put parentheses, but the 4 is times everything. So that's why you have extra grouping symbols. That's a good question. All right, so my x plus 3 is my common factor. I can write that outside. And then I'll reduce. And then you write what's left. You make your greatest common factors into a group. The greatest common factors are x squared plus 2. So I'll write x squared plus 2 as my final factor. And you double check and make sure, or triple check, that there's no more factoring to be done. X plus 3 can't be factored. X squared plus 2 can't be factored. So we're finished. But always look one more time at your final factored result and make sure that you're really actually finished. To check yourself, you could graph this in your calculator, this factored polynomial, and you could also graph the original one you were given, and the graphs should line up on top of each other. Whatever shape it is, they should represent the same points. It should be equivalent. And that's the quickest way to check and make sure that you didn't make any errors when you're factoring. I could write that on here, graph to check. Again, you would graph the final and the original, even before you factor out the 4. How'd that go? All right, good. So we'll move on and have a couple more examples here. 32x to the third minus 4x squared plus 24x plus 3. I'll go to this prime number to see if I have a common factor. My only factors of 3 are 3 times 1. So if I check these other terms, I want to know, are they divisible by 3? And not all of them are. So there's no greatest common factor. So the next thing to do is to make two groups, first two, second two. For the first group of two terms, my greatest common factor is 4x squared. For my second two terms, or sorry, my second group of two terms, my greatest common factor is 3. And the signs match the sign of the first term of the group. I can rewrite this as 4x squared times, I'll go ahead and simplify the fractions for this first group. That leaves me with 8x minus 1. And then I add 3, the greatest common factor for the second group, and reduce by dividing by 3. So that gives me 8x minus 1. And I can see my greatest common, or there's a common binomial. Both terms have 8x minus 1. So 8x minus 1 will be one of my factors. And my second factor will be what remains when I take the 8x minus 1 out. I mean, I just wrote it in the previous example. If we divide the entire polynomial by 8x plus 1 and then also multiply to balance, that's where this comes from. And you can write it that way if it makes it a clearer path for you. But what happens is this common binomial is one of your factors, and the stuff that's left over is your other factor, 4x squared plus 3. You make sure that you didn't miss a greatest common factor and there's no pattern, and there's not, so we're finished. And you could graph to check. I have two more. I'm gonna do one, and I'm gonna leave this third one for you. Let's move to this one because this one looks a little bit different. The difference is for my second group, I have a negative greatest common factor. So I'm working 56x cubed plus 64x squared. I'm gonna do that one next. So here, I look for a greatest common factor. All of the numbers are even, so I at least have 2. But 2 is going to be it because 14 is 2 times 7, and none of the other factors are divisible by 7. Well, 64 is not, and 8 won't be. So I pull out my 2. Oops. Go ahead and factor out 2. And I can write this as 2 times 28x to the third plus 32x squared minus 7x minus 8. You make two groups, first two, second two. For 28x to the third and 32x squared, the greatest common factor is 4x squared. For the second group, there doesn't appear to be any common factor, so you can take out 1. We're going to actually take out a negative 1 because the 7x is negative. And that is going to change my sign right here. If I divide everything by -1, then I have some sign changes. Just be careful about that. I can rewrite this again as 2 times 4x squared times 7x plus 8. And then the -1, I factored out of the second group. And if I divide both of those terms by -1, I change the signs. So I'll write this as 7x plus 8. And I didn't use bracket this time, but I do have 2 sets of parentheses. I do have a common factor in the first group and the second group. So my factors will be 2 and 7x plus 8 and whatever remains when I take out 7x plus 8. And that will be 4x squared minus 1. When you look at these factors, I can factor again. 4x squared minus 1 is a difference of squares. 4x squared minus 1 is 2x times 2x, so 2x squared minus 1 squared. And we'll factor that using our difference of squares pattern. So I can write 4x squared minus 1 as 2x minus 1 times 2x plus 1. And I have 7x plus 8. And I have a 2. So that's why I said make sure to check when you feel finished, when you've done the initial process, and make sure there are no patterns or additional greatest common factors. There's one remaining example here. And I'll have you guys work on that. You can work in your table groups. For the people on the video, pause this and work through it yourself, and then double check your answers. You can turn the video back on. I have this factored. You need to remember that a sum of squares is not factorable. If I had a difference of squares, if I had x squared minus 4, then I could factor that again. But x squared plus 4 is prime. That cannot be factored. So my final factors are x squared plus 4 and 5x minus 6.